Good morning friends, welcome back to Parnika tutorials. We know that process synchronization mechanisms are broadly classified into two types. One is the busy waiting solutions and another one is non-busy waiting solutions. In the last video, I have discussed what are the issues in the busy waiting solutions, and then I have discussed about non-busy waiting solutions, and then I have discussed about the producer-consumer problem. I hope you have watched that video. If you did not watch that video or if you don't know those concepts, I request you to go back and watch that video and come back to this video. In this video, I want to discuss about the semaphore and various types of semaphores such as binary semaphore and counting semaphore. So I request everyone to watch the complete video for better understanding. First, let me discuss what is the need for semaphore in the producer-consumer problem. Now, in the producer-consumer problem, we have a producer and we will have a consumer. Okay, now what is the duty of producer is he has to produce the items, and what is the duty of a consumer? He has to consume the items. Now we know that a count will be there. Okay, we will have a buffer. Okay, in that buffer, the whatever the items the producer is producing, he will keep the items in that buffer, and we will have a count variable which will help us to know how many items are there in the buffer. Is it clear? Suppose let's take the 10 items are there, then count value will be equal to 10. So we have a count, it will tell us how many items are there in the buffer. If count is equal to 0, then consumer will go to the sleep. Am I right? Because there are no items in the buffer to consume, so the consumer will go to the sleep. Similarly, if count is equal to n, meaning is that n is the limit in the buffer. Suppose let's take that n value is equal to 10. The meaning is that the buffer capacity is 10 items only. So the buffer can store 10 items. So if count is equal to n, meaning is that the number of items in the buffer is equal to the capacity of the buffer, then if the producer produce an item, where he will store, because the buffer is full. If the buffer is full, the producer will go to the sleep. Am I right or wrong? Similarly, if count is equal to 1, then producer has to wake up the consumer. Is it clear? And similarly, if count is equal to n minus 1, then what the consumer has to do? He has to wake up the producer. Is it clear? Are you able to understand it or not? Now look at here. If count is equal to 0, meaning is that there are no items in the buffer. So what the consumer will consume? He cannot consume anything. So instead of waiting, he will go to the sleep. Similarly, if producer has keep on producing the items, if count is equal to n, meaning is that the number of items in the buffer is equal to the maximum capacity of the buffer. So the buffer is full. Then producer, if he produce anything, then where he will store? There is no space to store the item, so he will go to the sleep. If count is equal to 1, let's take that count is equal to 1, meaning is that there is one item in the buffer. Then meaning is that producer thinks that maybe the consumer would have seen count is equal to 0. If count is equal to 1, before that, what will be the count value? Will be 0, because whenever the producer is producing the item, he will increment the count value. He will do count is equal to count plus 1. Once he keep the item, suppose now let's take that. How many items are there in the buffer? 0. Now one item was kept. Now what will be the count value? 1. So if count value is equal to 1, meaning is that before that count value is equal to 0. Then what the producer thinks that maybe consumer would have seen count is equal to 0 already, and he would have been in the sleep state. So when count is equal to 1, then there is one item which was produced by the producer, then he will wake up the consumer. Similarly, if count is equal to n minus 1, now what the consumer is doing? Once he consumes the item, he will decrement the count value. Is it clear? Once the consumer consumes this item, then count will become 0, because there is one item. That item was consumed by the consumer, then obviously number of items will become 0. So similarly, once the consumer is consuming the items, he is making the count value decrement by 1. Now once he see the count is equal to n minus 1, meaning before that is count value will be equal to n. So what the consumer will think, okay, before I consumed one item, there are n items are there. Maybe producer will be in the sleeping state, because if count is equal to n, that time producer will sleep up. So it is the duty of the consumer to wake up the producer. So this is the way the producer consumer problem will work. But there is one issue in this one. What is that issue is that, now let's take that buffer is empty, meaning is that there are no items in the buffer. Then what will be the count value? Count value will be equal to 0. Now let's see that consumer has seen the buffer. So count is equal to 0. There are no items in the buffer. So consumer cannot consume anything. So he will go to the sleep. Before he was about to go to the sleep, the process was preempted. Is it clear? Are you able to understand? Now producer has produced one item. Count will be equal to 1, because before that buffer is empty, count is equal to 0. Now producer has produced one item, count value will be equal to 1. So this condition is true. If this condition is true, he has to wake up the consumer. So he has generated a wake up signal to wake up the consumer. Now consumer is sleeping. No, he is not sleeping. So if the producer generates the wake up signal, the consumer is not sleeping, so that wake up signal will be wasted. Now after the wake up signal is lost or wasted, now the consumer is sleeping. Is it clear? Are you able to understand it or not? Now consumer is sleeping, thinking that there are no items in the buffer. And what the producer will think, I have wake up the consumer, and he will keep on producing the items. Now let's take that after some time the count is equal to n, because the producer is keep on producing and consumer is sleeping, he is not consuming any items. Then count value will be equal to n. Then what the producer will do, he will be in the sleep, because he will go to the sleep. Now producer is in the sleep and consumer is also in the sleep. What the producer will think? Producer will think, once the consumer consume one item, then count will be equal to n minus 1, he will wake up the producer. Are you able to understand? Similarly, what the consumer will think, right now before I sleep, count is equal to 0. Once the producer produce one item, count will be equal to 1, then producer will wake up the consumer. So both of them waiting for other process to wake up them. So now both the process are there in the sleep state, which is nothing but your block state now, or the wait state. Am I right? Now if both the process are in the wait state and they are waiting for other one to wake up them, then it is called a deadlock. So if there is only producer consumer, okay, then we will have the deadlock. Is it clear? Now how the deadlock can be overcome is with the help of a semaphore. So here what is actually happening, the producer is wake upping the consumer, but this wake up signal has been lost. Now if I can keep a one variable, okay, in that variable, whenever the producer or the consumer wants to wake up, they will keep this value 1. Is it clear? So the value 1 meaning is that one wake up signal was generated. Before the consumer goes to the sleep, he has to see this variable. If it is 1, meaning is that, okay, one wake up signal was generated by the producer, meaning is that there are some items in the buffer. So he will not go to the sleep instead of going to the sleep, he will consume the items. Are you able to understand it or not? It is simply like he is keeping one tag. Okay, this instead of giving the wake up signal, he is keeping one tag. Before the consumer has to go to the sleep, he has to look at the tag. If the tag value is 0, then meaning is that there are no wake up signals, consumer will go to the sleep. Otherwise, if the value is other than 0, then meaning is that, okay, wake up signals were generated, then consumer has to consume the items instead of going for the sleep state. So that is the purpose of this variable. We will call it as a semaphore. Is it clear? Are you able to understand it or not? Okay, and remember one thing, this semaphore variable will be operated in the kernel mode. Why it will operate in the kernel mode, I will discuss for you. Okay, now look, let me give a definition for the semaphore. A semaphore is an integer variable that can be accessed only through two standard operations such as wait and signal. Is it clear? Are you able to understand it or not? Now let me discuss what is the meaning of this one. Now look at here. And one more thing is that it works in the kernel mode. Why it operates in the kernel mode, I will discuss for you. Now semaphore is a one variable, am I right? Now producer is accessing this variable and even the consumer is accessing the semaphore variable. Okay, are you able to understand? There is a semaphore variable is there. Okay, now look at here. Whenever the process is going for the wait state, is it clear? Wait state, or we can say or a down operation, or we can say that p operation, is it clear? That time what the semaphore value will become, it will be decremented by 1, and signal is nothing but you are upping the process. So we can say that signal is nothing but up or v operation, is it clear? Meaning is that time semaphore value will be incremented. I will discuss about in detail how the semaphore will work when I am discussing about the binary semaphore and counting semaphore. Just now you think that semaphore is a one variable that can be accessed by both the producer and consumer. Is it clear? Are you able to understand? Now it is nothing but a shared variable. Whenever there is a shared variable is there, then obviously the issues will come, because now as there is a shared variable is there, now producer and consumer are nothing but the cooperating process. Now data inconsistency may come. Am I right or wrong? If we operate the semaphore in the user mode, then data of issues will come. Are you able to understand it? A consistency may not be there. Already we have discussed in the need for synchronization. Whenever there is a shared variable is there between the two cooperating process, what are the issues will be there. So that's why we have discussed the synchronization mechanism. So that's why what they have done, the semaphore variable, instead of using it in the user mode, it will work in the kernel mode. We know that we have two modes. One is the user mode and another one is kernel mode. User mode meaning is that it does not take any support from the operating system, whereas in the kernel mode it takes the support from the operating system. So semaphore variable runs in the kernel mode. Is it clear? Are you able to understand? So to avoid the data consistency issue. So I hope you have understood what is the need for the semaphore variable and why it runs in the kernel mode and why it takes the support from the operating system. Now let me discuss various types of semaphores. We have broadly have two types of semaphores. One is the binary semaphore and another one is counting semaphore. First let me discuss about the counting semaphore, then easily you will understand what is a binary semaphore. Okay. Let's take a simple example. You have a critical session. Okay. Usually we say that mutual exclusion should be provided in the critical session. So at max only one process can be allowed inside the semaphore. Let's take that we have three instances of a printer. Now if we have three instances of a printer, three processes can access the printer at a particular instant of time. Because if you have three instances of printer P1, printer P2, printer P3 is there, then this printer P1 can be accessed by some process X, and this one can be accessed by some process Y, and this can be accessed by some process Z. Suppose let's take that, meaning is that you can allow three processes to enter into the critical session. Am I right? Because now the printer is a shared resource. So that's why we know that whenever there is a shared resource or shared variable, if one process is accessing in that code, then we will say that it is a critical session. Is it clear? Now how many processes can enter into the critical session? Three processes. So you will have the counting semaphore variable. Let's take that CS. Its initial value is equal to 3. Meaning is that three processes can enter into the critical session. Now let's take that process P1 wants to enter into the critical session. Before it enters into the critical session, it will decrement the semaphore value by 1. This operation we will call it as down operation or P operation or wait. Is it clear? Are you able to understand? Any one you can use it. Okay. Now what will be the semaphore value, counting semaphore value? It will become 2, and then process P1 enters into the critical session. Meaning is that Now two more process can enter into the critical session. Now let's take the process P2 wants to enter into the critical session. It will look at the counting semaphore value. Is it clear? It is greater than 0. Is it clear? So there are more process can enter into the critical session. It will decrement the value by 1. It will become 1 and then process P2 will enter into the critical session. Is it clear? Okay, I think maybe you are confusing with this CS and this CS. This is the critical session, okay, and this is the counting semaphore. Okay, now how many processes are there in the critical session? Two processes are there, and counting semaphore value is equal to 1, meaning is that one more process can enter into the critical session. Now process P3 wants to enter into the critical session. What it will do? It will decrement the value by 1 and it will become 0. Then process P3 will enter into the critical session. Is it clear? Now how many processes still can enter into the critical session? 0 process. Is it clear? Are you able to understand? Now look at here. Process P4 wants to enter into the critical session. Again, what it will do before entering, it has to decrement the counting semaphore value by 1. So 0 minus 1, it will become minus 1. Now this value is less than 0. Is it clear? Counting semaphore value is less than 0. Then it will understand that, okay, what are the critical session? All the processes are already there. So this process will be in the sleep state. Means it will go to the sleep state. Are you able to understand? Now process P5 wants to enter into the critical session. Then again it will decrement the value by 1. It will become minus 2, which is less than 0. Now process P5 will go to the sleep state. Now in a counting semaphore, the negative value represents that. Now look at here, it is minus 2, meaning is that two processes are there in the sleep state. Is it clear? If it is a positive value, suppose let's take that if it is plus 2, meaning is that two more processes can enter into the critical session. This is the way the counting semaphore will work. Is it clear? Are you able to understand? Now you can ask me. So now let's take that process P1 has completed its task. Then what it will do? When the process P1 complete its task, it will increment the counting semaphore value by 1. That operation we will call it as up operation or V operation or signal. Is it clear? That's why we have used this terminology called wait and signal. Is it clear? Now process P1, once it is, because each critical session will have the enter session and exit session. So in the exit session, it will increment the counting semaphore value. Now minus 2 plus 1 will become minus 1 and it is less than 0. Then it will understand that, okay, some process are there in the sleep state. Am I right? So it will wake up one of the process. Is it clear? Are you able to understand it or not? If one process leaves, process P1 leaves, now only two process are there in the critical session. One more process can enter into the critical session. So it will, once the process leaves the critical session, it will increment that value and it will see the critical semaphore value. Are you able to understand? Once the process leaves the critical session, it will increment the counting semaphore value, and if the counting semaphore value is less than 0, then it will wake up one of the process which is there in the waiting state. Is it clear? This one we will use the queue. So a process which has entered first will leave. So it will queue, we know that it will work in the principle called first in first out. So the process which went to the sleep first, that will be wake up first. Okay, so this is about the counting semaphore. Now binary semaphore. Now tell me one thing, here the mutual exclusion is provided? No, am I right? Because more than one process is entered into the critical session. Now if you want to provide the mutual exclusion, then we can use the binary semaphore. In the binary semaphore, the semaphore value will be either 1 or 0. Is it clear? If it is 1, the process which wants to enter into the critical session can enter. Meaning is that the critical session is vacant. If semaphore value is equal to 0, critical session is occupied. Are you able to understand? So binary semaphore value can be either 1 or 0. If it is 1, the critical session is vacant. If it is 0, critical session is occupied. So I hope you have understood what is the purpose of a semaphore and why it runs in the kernel mode and what are the types of semaphores. In the next video, I will discuss about the counting semaphore in detail. Thank you for watching the complete video. Have a nice day.